Lesson 17.1, Task 3. Explore intersections, unions, and complements. The intersection of two events A and B, written as A intersection B or A and B, is the set of outcomes that are in both A and B. The union of A and B, written as A union B or as A or B, is the set of outcomes that are in A or B, or both. The complement of A, written as A raised to the C, or as not A, is the set of outcomes in the sample space that are not in A. These concepts are illustrated in the Venn diagram. All right, so this does make it easy to see. So if you have an intersection, it's only the part that overlaps that intersects. That is the solution. So all points inside this area would represent A intersect B. All right, for union, union is all things in A and B. You can see here's where they overlap and they share certain things, but you can see that all these are shaded. So just think of union like a marriage. So when two people get married, all of your belongings become common territory, so or shared properties. All right, so we've got A to the C is shaded, so this is our complement. So A complements C. So everything outside of A complements A. So everything in B, but not in A, is A complement. All right, so those visually help you see what we're talking about. All right, so it says, suppose you spin a spinner shown. Let event A be getting a multiple of 3, and let event B be getting a number less than 8. The events A and B are represented in the Venn diagram, where S is the sample space. All right, so again, you have your spinner. So we've got numbers 1 through 12. And it says event A is your multiples of 3. So here's my multiples of 3. So it says A, 3, 6, 9, and 12 all represent event A. And then event B is getting a number less than 8. So we've got 1, 2, 3, 4, 5, 6, 7. All of these numbers are less than 8. And they have 2 that they share. So 3 and 6 are both in set A and B. All right, so it says write A and B as sets of outcomes. Select the outcomes in each set. All right, so A is our 3, 6, 9, and 12. And B is everything less than 8. All right, describe in words what the events A intersect B, A union B, and A complement and B complement mean. All right, so A intersect B is the set of integers from 1 to 12 that are multiples of 3 and less than 8. All right, so it has to be both this and this. So remember, when it's intersect, it's only the part that meets both requirements, so the intersection part. A union B is the set of integers from 1 to 12 that are multiples of 3 or less than 8. Remember, a union is now shared property, so if it's in either one, then it makes it true. All right, so A complement is the set of integers from 1 to 12 that are not a multiple of 3. Because remember, set A is a multiple of 3. We're looking for the complement, which are not a multiple of 3. And then the B complement is the set of integers from 1 to 12 that are not less than 8. All right, so write A intersect B, A union B, and A complement and B complement as sets of outcomes. Match the number in each set with its set of outcomes. All right, so A intersect B. We can see A intersect B is 3 and 6. We know that A union B is 3 and 6 plus all numbers less than 8. So that would be this set here. A complement, so that means everything in B that's not in A. So everything in B right here that's not in A would be 1, 2, 4, 5, and 7. And I forgot to mention, but 8, 10, and 11, these three numbers are not in A or B, so that's why those are listed as well. All right, so B complement would be everything not in B. All right, so what are probability of A intersect B and the probability of A union B and the probability of A complement and B and the probability of B complement? All right, so A intersect B had 2 out of 12. 2 out of 12 reduces to 1/6. A union B has 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 out of 12. 9 out of 12 reduces to 3 out of 4. And the complement, so A complement is everything in B. So we got 1, 2, 3, 4, 5, 6, 7, 8 out of 12, which is 2/3. And that leaves probability of B complement as 5/12. All right, so it says verify that the following equation is true for the given event A. Probability of A plus the probability of A complement equals 1. All right, so that is true because if you've got the probability of A, here's the probability of A, and then the complement would be all of these plus this, this, and this, and so that would equal everything in the spinner. So that's always going to equal 1. All right, so it says verify that. So we can verify that by saying the probability of A. What is the probability of A? Probability of A is 1, 2, 3, 4. 4 out of 12. 4 out of 12 is the same as 1/3. And then we already found A complement. A complement was 2/3. So all we have to do is say that 1/3 plus 2/3 equals 1. Okay, so that shows that a sample space and its complement should equal 1 always. All right, so the equations in part E can be rewritten in either of the following forms. P of A equals 1 minus the probability of A complement, or the probability of A complement equals 1 minus probability of A. All right, so this is just another way of basically using this right here for our benefit. If you know that the probability of A plus the probability of A's complement equals 1, then sometimes it will make it easier to find the complement than it would be to find the actual space you're looking for. So if I need to find P of A, but it's more convenient to find the probability of A complement, then I can first find probability of A complement and subtract the probability of A complement from 1 to find P of A. All right, so that just makes it easier sometimes to solve when you have different information than maybe you necessarily need. All right, that's all for task 3. If you have any questions, let me know. Lesson 17.1, task 4. Calculate probabilities. A DJ is using a 200-song library of music for a party. The table shows information about a DJ's music library. All right, for genre, there's country, hip-hop, pop, and R&B. And underneath that, it's the number of songs for each one. All right, so a guest at the party selects a song at random from the DJ's library. Find the probability of each event expressed as a percent. All right, so there's 3 scenarios. The song is a country song, the song is hip hop or pop, the song is not R&B. So here's how they found the probability. So the probability of country is going to be 26 out of the total amount. So if you add those up, there would be 200 total songs on the DJ's playlist. All right, so 26 out of 200. Okay, if you calculate that, 26 divided by 200. It's going to give this to you as a decimal, 0.13, and you have to change that to a percent. Remember, to go from a decimal to a percent, you move it 2 decimal places. All right, so hip hop or pop. Hip hop or pop, so that's a union, so you have to combine those. So 60 and 72. So you want to find the probability of choosing a song from one of these 2 genres. And to do that, you add those together. So it'd be 132 out of 200. So 132 divided by 200. And that gives you the 0.66 or 66%. So your chance of hearing a hip hop or a pop song from this playlist would be 66, almost 2/3%. So the probability of not choosing R&B. So R&B is 42. So if you want to find the probability of not choosing this, then it's going to be all of these without R&B. So the way they're going to do this is going to be the 1 minus the probability of R&B. So 1 minus the 42 over 200. Okay, so remember we looked at this before when looking at the complement. And so 1 minus this would give you the 158 over 200 or 79%. All right, looking at the probability of hip hop or pop, why is the numerator or the fraction 60 plus 72? All right, so again, if it says or, that means union, and that means you're going to combine those. So the numerator can be written as the sum of the number of outcomes in each set, since we are considering the union of the 2 sets and their intersection is empty. All right, what is another way to find the probability of not R&B? Okay, so they found the complement, and they did 1 minus the complement. Another way to find that would be simply to add these 3 numbers up and divide them by 200. So that would be country, hip hop, or pop. All right, that's all for task 4. If you have any questions, let me know.